divisibility tests. So how do we check if a certain number is divisible by another number with no remainders? So to know if it's divisible by 2, the number just has to be even. So 10 is even, so it's divisible by 2. And if you do 10 divided by 2, you'll get 5 with no remainders. How do we know if a number is divisible by 3? Well, to know that, we've got to sum all the digits of that number together. And if that sum is divisible by 3, then the original number is divisible by 3. So let's look at an example. Is 12 divisible by 3? Well, we can do the digits of 12 are 1 and 2, so we add them together to get 3. And we know 3 is divisible by 3, so that means the original number 12 is also divisible by 3. What about 729? Is that divisible by 3? Well, let's get all the digits, 7, 2 and 9, and add them all together. And that's going to give us 18. And if you didn't know if 18 was divisible by 3, you can even add those digits together, the 1 and the 8, to get 9. And 9 is divisible by 3, so the original number is divisible by 3. What about 4? 4, the last 2 digits have to be divisible by 4. Or the last 2 digits are 0, 0. So if we have 100, the last 2 digits are 0, 0. So 100 is divisible by 4 because you get 25. What about 144? Well, the last 2 digits are 44, and 44 is divisible by 4 because we get 11. So therefore, the original number is divisible by 4. 5. It's an easy one. The number just has to end in a 0 or a 5. So 10, 125, 1,250, all divisible by 5 because the last digit is either a 0 or a 5. What about 6? It has to pass the test for 2 and 3. And that's because 2 times 3 is 6, which means it has to be even, and the digits have to sum to a number divisible by 3. So let's check 72. Well, 72 is even because it ends in a 2. And if we sum the digits of 72, so 7 plus 2 is 9, and 9 is divisible by 3, so it passes that test for 2 and 3, so the original number is divisible by 6. Alright, 7. This is the trickiest one. So let's look at 1,603. Is that divisible by 7? What you have to do is take off the last digit and double it. So 3 times 2 gives us 6. And subtract this from the remaining digits of the original number. So we're going to do 160 minus 6, which gives us 154. Then if that number is divisible by 7, the original number is divisible by 7. But if you didn't know if 154 was divisible by 7, we can go again. So take off the last digit, double it, so times it by 2, gives us 8, and we subtract 8 from the remaining digits. So now we're going to do 15 minus 8, which is 7. And we know 7 is divisible by 7, which means the original number of 1,603 is divisible by 7. What about 8? So for 8, the last 3 digits have to be divisible by 8, or the last 3 digits are all zeros. So let's look at 1024. The last 3 digits are 024, which is just 24. And we know 24 is divisible by 8 because we get 3. So therefore, the original number, 1024, is divisible by 8. What about 10,000? Well, the last 3 digits are all zeros, so we also know that that's divisible by 8 as well. 9. The sum of all the digits in the number has to be divisible by 9. So let's look at 333,333. We have to sum all these digits together. So there's 6 threes here. We need to add. And if you add that together, we get 18. And 18 is divisible by 9 because we get 2. So therefore, the original number is divisible by 9. What about 10? This is the easiest one out of the lot. The number just has to end in a 0. So 20, 1,000, and 20 million are all divisible by 10 because they end in a 0.